Good day everyone, welcome to JD's channel. Today, we're going to discuss another topic. Don't forget to like, share, and subscribe for more tutorials. Thank you and God bless. Good day everyone, welcome again to JD's channel, and for today's topic, we are going to discuss all about efficiency and losses. So let's get started. Efficiency and losses. Efficiency is the ratio of electrical power out of the alternator to the mechanical power put into it and is usually expressed as percentage. So, ito yung ating formula class. So, yung ating symbol for efficiency is equals to power output over ng power output plus yung ating power losses. For the losses, so for alternator or ayan yung ating AC generator, these losses are so yung ating rotational losses such as friction and windage, the eddy current loss, and the hysteresis losses in magnetic circuit. So yung eddy current and hysteresis losses class is yan ay bumubuo dun sa ating tinatawag na iron loss, or the other term is the core loss. Okay? And thirdly, the copper losses in the armature winding and in the field coils. And lastly, yung ating load loss due to the armature leakage flux causing eddy current and hysteresis losses in the armature surrounding iron. So dito class, ayan, ito yung ating formula. Bali, class ito, nakasum up lang. So, yung ating power losses is equals to the, yung ating loss sa copper, yung ating loss sa friction and windage, yung ating loss sa core loss or iron loss. So, nandito yung ating eddy current loss at saka yung hysteresis loss. And then yung ating field winding loss, yung ating ventilation loss, and then yung ating stray load loss. So for the power output naman, we have itong formula na BL IL cosine theta, yun ay para sa ating single phase. And then for 3 phase, we have the squared ng 3, BL IL cosine theta. For the copper loss, we have the I phase quantity squared multiplied by armature resistance per phase, or yun ay para sa ating single phase. For the 3 phase, we have 3 multiplied by the I phase quantity squared multiplied by the armature resistance per phase. Okay, so for the field winding loss, we have this power loss sa field winding, that is IF squared multiplied by the resistance sa field. Also equals sa IF multiplied by the voltage sa field, or yan yung ating voltage sa field squared over ng ating RF. So ito class yung mga parameter, yung kanilang mga units. Ano po? VL is the line-to-line voltage in volts. IL is the line current in ampere. I phase is the phase current in ampere. Cosine theta is the load power factor. The ECU or yung ating copper loss is the armature winding copper loss in watts, and friction windage losses Then yung ating is also in watts. For losses or the iron loss, that is also in watts. Ito yung composed ng eddy current and hysteresis loss. And yung ating stray load loss, that is in watts also, and the ventilation loss in watts. And then the field winding loss in watts, field current or the exciter current in ampere, the field resistance in ohms, the armature resistance per phase, that is also in ohms, and the voltage across the field winding in volts. So reminder lang class that the friction and windage loss, the field loss, the core loss, stray load, and ventilation losses are constant losses. Okay? Unless otherwise specified. So sa ibang problem, so minsan may ilan na hindi nakakasama, but then so class ito ay constant losses. Ano po? So itong mga loss na ating napag-usapan dito. They are constant losses. Okay, so another thing is the armature copper loss at any size of the load. So ito kasi class merong kindang load wherein yan. Gumagamit din tayo ng formula para sa copper loss natin. So yan, so yung ating copper loss at any size of load is equals to yung size ng load, which is the X, multiplied ng ating full load copper losses. So yan, X is the percentage loading on the alternator. So kung anong size man yan. Then the copper loss, at yan nga yung ating at X% load, and the full load copper losses. Yan, i-multiply natin doon. Ano po? Para makuha natin yung ating copper loss in a specific size ng ating load. So, ayun class, those are the discussion, theory, formulas, and parameters ng ating efficiency and losses for the alternator or AC generator. So, we go now to the sample problem para may apply natin yung ating mga na-discuss kanina lang. For the sample problem, so, determine the efficiency of a 1,500 kVA, 2,300 volts, three-phase Y-connected alternator which operates at rated output with a power factor of 80%. The DC armature resistance between terminals is 0.08 ohms. The field takes 70 amperes at 120 volts from the exciter equipment. Friction and windage losses are 15 kilowatts, iron loss is 35 kilowatts, and stray load losses are 1.5 kilowatts. Assume the effective armature winding resistance is 1.5 times the DC value. So, yan. Class yung ating given. So, yan yung ating problem. So, be ready with your calcu and notebook. So, at sabay-sabay tayo mag-solve. So, let's go. For the given class, we have the apparent power that is 1,500 kilo volt ampere, and the V line natin that is 2,300 volts with a power factor that is 80%, and the RT that is 0.08 ohms with the ratio that is 1.5 ng RTC natin yung ating RA, and the ating field current that is 70 amperes. And yung ating voltage at field is 120 volts with three-phase Y-connected alternator, and yung ating loss sa friction and windage, that is 15 kilowatts, sa core, that is 35 kilowatts, and the stray load, that is 1.5 kilowatts. Okay, for the required class, we have, yan na yung ating efficiency. For the formula class to be used, ayan yung ating, ito na yung ating formula. So, okay, so mag-start tayo dito. Ano po, dun sa ating mga field loss, field winding loss. Ayan yung ating copper loss. Then, pagsama-samahin lang natin siya dito sa losses. And then, doon na tayo sa ating efficiency. Solution. So, finding the IPs. So, I is equals to S over ng square root ng 3 VL. So, substitute na natin yung ating value, that is yung ating S and VL. So, yung ating 1,500 kVA over the square root ng 3 multiplied by 2,300 volts. So, the I phase is equals to, ayan, so yung 376.532784.3 ampere. Finding the RDC naman class. So RDC is equals to yung ating RT over ng 2. And RDC is equals to 0.08 ohms over ng 2. And the value of RDC is equals to 0.04 ohms. And then finding for RA naman class, we have the ratio, that is R is equals to 1.5 ng ating ohmic resistance. So, i-substitute lang natin yung ating nakuhang value for RDC, that is 0.04 multiplied by 1.5, and then RA is equals to 0.06 ohms. And then the next one class is we need to find yung sa losses na tayo class. So yung ating copper loss, that is equals to 3 times yung ating I phase squared multiplied by the armature resistance per phase. And then substitute lang natin yung ating I phase and ating RA, that is 3 times 376.532784.3 ampere squared multiplied by 0.06. So the answer would be 25,519.87878 watts. Finding for the field winding loss. So ito yung ating formula. So yung ating BF times IF, which is 120 multiplied by 70. And then the value of RPF is equals to 8,400 watts. Okay, so class, ito na tayo sa ating P losses or power losses. Okay, power losses is equals to yung ating loss sa copper, sa field and windage, and yung ating copper loss, yung ating core loss or the iron loss, yung ating field winding loss, and the ating straight load loss. So for the copper loss, we have yung ating 25,519.8487 8 watts. For the windage, friction and windage loss, that is 15 kilowatts. For the core, that is 35 kilowatts. For the field, yung ating nakuha kanina, that is 8,400 watts. And for the stray loss, that is 1.5 kilowatts. So to sum up, ang ating value ng P losses is equals to 85,419.84878 watts. That is the total power losses natin. And the next one, class, is, ayan, so dito na tayo, class, sa ating final, that is yung ating efficiency. Efficiency, again, is equals to the power output over the power output plus yung ating power losses. Okay, substitute na natin. Again, yung ating power output, multiply lang natin yung ating S. Okay, that is yung ating 1,500 kVA multiplied by yung ating power factor. Ano po? So that is our power loss. That is our power output. Yan, mga power formula natin. Ano po? Power output. And then ito din po yon. And then yung ating nakuhang power losses kanina. That is 85,419.8487 watts. And then input naman po, and ano yung ating sagot? That is 0.93 35 47 12 17. So obviously alam na natin yung magiging percent. Ano po, i-times lang natin by 100 para siya ay naka-percent. So the final answer of our efficiency would be 93.3547%. That is the efficiency. So check natin, class, kung tama yung ating sagot. Final answer, ayan. So final answer is 93.3547%. So that would be all, class, for this tutorial. Thank you. Keep safe and God richly bless you. Hope that you get something and you learn something from this tutorial. And don't forget to like, share, and subscribe for more tutorials. So thank you, class, and to God be all the glory. So thank you and keep safe for everyone. God richly bless you.